This is the second part of 3.1. What we're going to talk about here is in the original one, we talked about finding maxes and mins, and we had talked about finding the derivative, setting it equal to 0, and then we were using our number line to determine whether they would be maximums or minimums. Now we're going to talk about an absolute minimum and maximum. And in this case, what we need to understand is that absolute just simply means one. Like, what is the actual highest point and what is the actual lowest point. So instead of us having multiple maxes and mins, we should only have one absolute max and only have one absolute min at the very most. Okay, so what is given to us is a graph here, and it's the graph of the function that we're going to do. So the answers are already given to you, but I'm going to show you how we're going to use the calculus to actually get there. So the function we have here is 3x to the fourth minus 4x to the third. So what we're going to do is we are still going to take the derivative like what we always have. That's not going to change. We're still going to find f prime of x. So f prime of x is equal to 12x to the third minus 12x squared. We're still going to set it equal to 0 and factor. So we're going to pull out a 12x squared, and then we're left with x minus 1 on the inside. So we know that we have our extreme points are going to be x equals 0 and x equals 1. So then, of course, we're going to set up our number line. Do this first, always. So we're going to set up our number line with 0 and 1. We're going to plug values of each of these intervals in. So I'm going to plug in -1, and I'm going to get negative. I'm not going to plug it in. I know you guys can do that on your own, but you're going to get negative when you plug in here. You're going to get negative when you plug in here, and you're going to get positive when you plug in here. So we already know that x equals 0 is neither. So that's not going to be something that we use, so we don't care about that. X equals 1, since we're going from negative to positive, you can kind of see negative to positive right here. That's going to be a min. Okay, so we know that's a min. Now, whether that's an absolute min is a different story. So what we're going to do is we're talking about finding maxes and mins on closed intervals. So that's where this comes in right here. They're telling us what our endpoints are, and you can see the endpoints are labeled on the graph. Now, what you want to understand is this. It does not matter at first what the y value is on each of these. You first have to determine whether the endpoints would be considered a maximum or a minimum. And the thing is, again, it doesn't matter what the y value is. It matters what the function is doing as it approaches it. And notice, as we come from the right here, we're going up to a point. So the only thing that we could ever call these is a possible endpoint maximum, because we're not going down to a point, we're actually going up to a point on both sides. So what we're going to do then is and again, this is assuming that you don't have a graph for the most part. So what we would do is we would plug each of these values in. So we're going to plug the -1 in, because that's what the endpoint is. The endpoints are given to us. So what we're going to actually do is we're going to figure out what is f of -1. So we would actually plug that into our function, our original function. So 3 times -1 to the fourth power minus 4 times -1 to the third power, and we get 7. So that means f of -1 is equal to 7, and you can see that's what the y value was up there, so we know that we did that right. Then we plug in the other endpoint. F of 2 is equal to, and again, I'm just going to plug it in, but I'm not going to actually write it down and plug it in here, and we get 16. Now, keep in mind, both of these were possible endpoint maxes. Possible endpoint maxes, not mins. But there can only be one absolute max, and it's the one that's at the highest point, so that's why it has to be this one. So what we can say is, because we have no other mins anywhere on the graph, there's only this one min, we know that that is not only a relative min, but it's our absolute min. So x equals 1 is our absolute min, and x equals 2 is our absolute max. Now, that's it for this problem. So the only thing that you should be aware of is that sometimes if we were to have an endpoint min possible, then you would actually have to compare what the y value is at x equals 1 and what the y value is at x equals whatever our endpoint min possibly was. Remember, you can only have one absolute of each, so it's going to be the lowest point for the absolute min, and it's going to be the highest point for the absolute max. But you have to find your regular maxes and mins like we have before. Then you have to determine your endpoints and whether those endpoints would be a potential max or a min, and then plug in your values and see which ones are higher. So this should be a really, really easy concept. It's only one thing that we have to do. Hopefully it makes sense. That's all I have. I don't have anything for you to do on your own, so I will see you in class.